Okay, so I'm gonna keep the lights on because I think it's actually just fine with the screen. Back in the before times where we had those projectors, it was really hard to see the screen with the lights off or the lights on. So one more skill we're learning, and we talked about the last skill, percent yield, during the lab. But the last skill we're doing today, or the skill we're doing today, is gas stoichiometry, and you can easily convert not just grams, but liters if you have a gas density. And the unit after this one is all about gases. So this is a pretty good segue to the next unit. So gas density are always given to you in a number of grams per liter, and it's usually close to 1, usually in the neighborhood of 1 gram per liter. But gas density is a number of grams per liter. And all you do is you either add a block at the end when you have grams and you're converting to liters. So if you had grams of something, so let's say you ended everything and it ended with grams of O2, then you would simply add grams of O2 to liters of O2. That's it, whatever the grams is. Sometimes you start with volume, like you have 32 liters of O2, and that's what you're going to start with. Then you simply say, for every 1 liter of O2, I have so many grams of O2. Okay? So you're just adding one more box to the end or the beginning. That's gas density. So we're going to do one together, just like before, and then the remainder will be for you to practice. Any questions before you begin?
So I'm assuming my question will be answered later on.
Okay. Oxygen density is 1.43 grams per liter with a mass of 5.96 liters of O2. So as a good practice, this is just a tiny little one-step T-chart. We have 5.96 liters of O2, so 5.96 liters of O2. So that can be easily converted into grams by realizing that for every 1 liter of O2, the density is 1.43 grams of O2. So it's just that simple. If you have liters up here, you're bringing liters down here. I don't know what that is. Looks like 10-ish. Doesn't matter. This is the important one. You ready? Okay. What volume in liters of CO2 is equal to 3.15 moles of CO2? So work this one out. So we're going to start just like before, only in this case we're starting with moles. We're not starting with grams. We're starting with moles, and we have 3.15 mole CO2. And to use gas density, we need to turn our grams. We need to turn our moles into grams first, and then to liters. And for every 1 mole of CO2, there's 44 grams of CO2. If you understand where the 44 grams of CO2 came from, point to where it came from. Right, it's like there on the periodic table or there on the wall. Right. So gram per mole comes from the periodic table. So we've converted our moles of CO2 to grams of CO2. Lastly, we need to convert that grams into liters. So we move down our grams of CO2, convert to liters of CO2, and the gas density that is given is for every 1 liter, it's going to weigh 2.00 grams. So that's it. Just add one more box. If you have liters, convert it to grams. If you have grams, convert it to liters. All right. Questions? We're good?
Yeah.
If you feel comfortable converting grams to liters, liters to grams, give me a thumbs up. If any of this is unclear, wave your hand around. All right, so this one's for you. There's your chemical reaction again. If 11 grams of H2 and 98.2 grams of O2 react, what volume of H2O gas will be produced? The density of water vapor, H2O gas otherwise, is 0.800 grams per liter. So, first of all, how many reactants are given? 2. So what kind of reaction is this? What kind of exercise is this?
Limited.
It's a limiting reactant exercise. But instead of going to grams of H2O, you're going to volume of H2O. All right, I'm going to shut up and let you work.
Are you?
Sure. Put your phone in the box. Need your foundation. But I'm being sneaky.
Because I bought that handle, but not the disc. So I think because I want to find it, I just make sure it doesn't
What could possibly be similar to that?
Did you get 122.5? Yeah.
Anyone having trouble getting started? We're good?
Why?
Okay. Do we need more time?
Yeah.
A little more time? All right, a little more time.
So it's 0.123.
Brandon, did you get?
Okay.
You got it.
What'd you get?
123.8.
It's like a little.
It's not 0.123, it's not that.
Brandon's actually got 123.75.
Grant readers are I just like started it and then have 101. Wait, no. Wait, 1 liter. Yeah, so that means we would have like 120,000. Yeah, and then later. So there's no way. It has to be. Well, it does make sense. So you have to divide that with a gram of having less. You just have to divide by, because then watch it, you divide that by 100.
Shook itself apart. The nature of the thing just shook the screws apart. All right. You know what? We got something special for John. So let's do that. So this is a limiting reactant exercise, and we got 11 grams of H2. And we're eventually going to end at liters of H2O. And we also have 98 grams of O2. 11.0? That should be 11.0. Well, anyway. Now again, in a limiting reactant exercise, you're given two reactants, and you need to come up with the same product in both cases. So we need to convert our H2 to moles. Why do we need to convert it first to moles? Why do we do that?
You can't go straight from mass to moles with each different element.
Exactly, you're converting to a different compound. The only way to convert to a different compound is with moles. So we're going to convert our grams of H2 to moles of H2. And the periodic table tells us for every 1 mole, there's 2.02 grams. Same thing with oxygen. We need to convert our grams of oxygen to moles of oxygen. And the periodic table tells us for every 1 mole, there's 32.0 grams. Good so far?
Yeah.
And now that we have moles, we can convert to the chemical we want, which is the H2O. So for every 1 mole, 2 moles, right? For every 2 moles of H2, I have 2 moles of H2O. And you're like, why is it 2? Because on the periodic table, or sorry, on the balanced chemical equation, there's 2 H2O to 2 H2. Now with oxygen, it's only 1. 1 mole of O2 is 2 moles of H2O. We're almost there. Now that we have moles H2O, we can start moving towards liters, so we need to get the gas first. For every 1 mole of H2O, the periodic table tells us it's 18.0 grams of H2O. For every 1 mole of H2O, it's 18.0 grams of H2O. Looks like I'm hitting my whiteboard after this exercise. Okay, finally, we've got grams of H2O. The exercise wants liters. So grams H2O to liters of H2O. Now we're using our gas density, and the gas density of water is 0.800 grams to 1 liter. 0.800 grams of H2O to 1 liter of H2O. And that's going to produce 2 answers, and we're going to choose the least. If hydrogen is the limiting reactant, how much water vapor do we make? Anyone have an answer for me?
I got 11.25.
Really? 11.3 liters H2O?
What? Yeah.
Can we get a second to that? I don't know if it's right or wrong. I can't memorize this stuff.
Yeah.
Brandon?
98.
You got 98 liters of H2O?
What? Oh wait, never mind.
At 11.3? Okay, there's 25 here. Surely more than, what do you got?
I got 123.
123? 123.8?
Yeah, that's why not.
124 liters of H2O. So I got a second to that one. That will look better. Okay? And sounds great. Now, if oxygen is the limiting reactant, how much liters of water will we make?
I got 138. They're not four, so they don't want.
139? 138?
Yeah.
Liters of H2O. Can we get a second on that one? Looks good. Okay. So which one is the limiting reactant?
First one,
Hydrogen. So the hydrogen is our limiting reactant, and we're going to make 124 liters of H2O. All right. How are you feeling about this? If this whole gas density thing makes sense, give me a thumbs up. Okay, question.
So on the thing, I just did separately which one is the limiting reactant, then converted it.
That's fine.
Okay.
So you got to grams and then converted the grams to the liters?
So I'm just asking if I'm doing it right. So I put 11 grams of H2 and this 4 grams of H2 makes 2 moles of H2O. Is that
Don't do that.
wrong?
Yeah, don't do that. You can confuse yourself. One, you'll confuse yourself because your units won't cancel. And 2, yeah, I won't give you partial credit if your units don't cancel. So don't take shortcuts. Don't do any kind of math until we're at the very, very end. Do grams to moles, then the mole ratio, then mole to gram, and off you go.
How do I know when to simplify or not? You put 2.02 and I just put 2. Does that matter?
I got yelled at in 6th period, last period. They're like, but it's 2.02. It doesn't matter.
Okay.
It's a rounding error.
All right.
I was like, okay, fine, technically it's 2.02, but doesn't matter. It really doesn't matter. Okay, other questions? All right, are you comfortable doing this on your own in a worksheet and a skills test?
Yeah.
All right, then I'll let you. Go for it.